For question 6, I wanted to compare the trees that are formed by using clustal versus using muscle. So I'm going to do clustal first. I'll show you what you would do. So here, clustal. If you look up here, so we were looking at the alignment, but there are other things you could be exploring. And I think I told you to look at the phylogenetic tree. Let me look at the question again. That's question 6. Yeah, look at the phylogenetic tree. And we're going to leave the branches as cladogram. You're going to learn what that means. But I can already tell you that that would not necessarily mean that this length carries meaning of genetic distances. If we did real, then that's more reflects more how far they're from each other. But the cladogram, sometimes it's just easier to follow the phylogenetic tree. You're going to learn to interpret these, but the way we follow cladogram or a real tree, it doesn't matter if it's the additive or the cladogram. Yeah, whatever is coming from these two branches, then these two are the most closely related to each other. And then there is this one is the next one that's the most closely related, which you might find is a little surprising. You might have postulated that kiss 1 and kiss 2 of zebrafish are closer to each other than the frog and the zebrafish kiss 2. So this is actually showing to you that so this is showing to you that kiss 2 is these two are more similar to each other, even though they are in different species, than kiss 1 to kiss 2. All right, so this formed that branch of these two being the two closest ones, and the two least related to all of them are the human kiss 1 and the mouse kiss 1, because they don't meet the node. So it's basically the way you follow this is from the inner branches going outward. So these two are the two most closely related. Then you go to the next one. So that one is closely related to these two as a group. And then you go out, and then this one. So let's see what the phylogenetic tree looks like when we looked at muscle. So yeah, this one. All right, so you click here, phylogenetic tree, and you're like, oh, that looks different, right? So still zebrafish groups closer, or the kiss 2 groups closer to kiss 2 with frog than zebrafish to kiss 1. But then you also have this group of opossum and mouse. They're close to each other. So this exercise is to show to you that even though they're the same sequences, then depending on how you do the scoring, you might come up with different trees. I like to compare this with, it's kind of not an awesome analogy, but maybe makes you understand why that happens. Maybe you are grouping your clothes and your rule was to group by color. But then you realized that you were not wearing the right clothes for clubbing or going to school, going to work. And then you're like, okay, maybe I should organize by the function. When I wear, like, I don't wear pajama. Well, in pandemic we do. But so it depends on how you are doing this scoring. That's how you're going to group the same things, but making different groups. So that's one way to think about how the different phylogenetic trees come about, even though the sequences were the same. And the reason why that happens is that they might use different rules for scoring, and they use different statistics to make the decisions of how the branches are going to go.